Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about solve by factoring word problems. And specifically with this video, we're going to use a traditional factor by grouping method to solve this problem. So let's dive right in. The length of a rectangular pool is 3 feet more than twice the width. The area of the pool is 65 feet squared. Find the length and width. And then I did note down here, because this is going to be helpful to us shortly, that the area of a rectangle, the formula is length times width. Anytime we have problems like this, I try to think, which side do we know nothing about? The length of the pool is 3 feet more than twice the width. We know a lot about the length, but we really don't know anything about the width. So when that happens, we can just label our width, which is right here, W. Now the length, it says up here, is 3 feet more than twice the width. 3 feet more than indicates to me that we're going to be adding 3, but twice the width tells me that we're going to take that W, our width, and we're going to double it, right? Anytime you twice something, that means we times it by 2. So we're going to take the width and we're going to double it. And then it's 3 feet more than that, so we're going to add 3 feet. They tell us the area of the pool is 65 feet squared. So I know, looking at this formula, I know the area, I know the length, and I know the width. So I have everything I need to be able to write an equation. In this instance, I'm going to actually do width times length. And the reason why is my width is just a monomial versus my length, which is a binomial. So it's just going to look better to do the width first. It doesn't really matter. With multiplication, we know that order doesn't matter. So I'm going to do width times length. And I know that those two multiplied together is going to give me 65, our area. So now we just want to solve this problem. I recognize that anytime we have parentheses, we need to distribute what's in front into the parenthesis to get rid of it. And in this case, that's going to be a W. So we need to multiply that W into the parenthesis set. W times 2W, that is going to be 2W squared. That goes back to our laws of exponents. This W has an exponent of 1, as does this W. And anytime we multiply with exponents, we add the exponents. So 1 plus 1 is 2. Okay, so next we do W times a positive 3, which would be a positive 3W, and it equals 65. Now, at this point, we want to recognize that we have a quadratic. A quadratic is when our highest exponent power is 2. And the way we typically solve quadratic equations is going to be by factoring. And again, I said in this video that we're going to be using just a traditional factor by grouping method. The first thing we want to recognize about this quadratic equation is that it's not in standard form. Standard form for a quadratic is ax squared plus bx plus c equals 0. This is close to being in standard form, but we don't have an equal 0. We have an equals 65, and that's very important. We can't factor this until we have an equals 0. So that means we need to move this 65 over to the other side of the equation. We can do that by subtraction, because this is a positive 65. So I'm going to subtract 65, cancels on this side, do the same thing to the other side. Now, I can't combine that minus 65 with the 2W squared or with the 3W. And the reason I can't is they're not like terms. None of those are like terms with each other. That one's a W squared, that one's a W, that one's a constant. It has no W. What I can do is just rewrite this. 2W squared plus 3W minus 65 equals, and now it's 0 because our 65's canceled. So now we've got an equation, a quadratic equation that is in standard form, and we can go ahead and factor it. Now our first step of factoring is going to be to label what is our A, B, and C. Now A is 2. It's that coefficient right in front of the x squared, or in this case, w squared. Our B is going to be the coefficient right in front of the just plain x or the just plain w. In this case, it's a positive 3. And our C is our constant. It's going to be the one with no letter attached. In this case, it's a negative 65. Once we know our A, B, and C, we can build this x. Now the way this x works is the top of the x, this little top V here, we put A times C. And in the bottom of the x, we put our B value. Now in this case, A times C, so that would be a 2 times a negative 65. That's going to give us negative 130. And then in the bottom, our B value is a positive 3. Now the way this x works is that we are looking to fill in these two sides of the x. And the way we do it is we need to find two values that multiply and give me the top, and add and give me the bottom. So I need two numbers that multiply to give me negative 130 and add to give me 3. Now let's think about our signs for just a second. If I'm multiplying two numbers, and I don't know what the numbers are, but I know that I'm multiplying them, and I'm getting a negative number, then that tells me my signs have to be a negative and a positive. That's the only way I can multiply and get a negative. So now I just need to think, okay, I've got my signs. What are my numbers? There's a lot of things that go into 130. How do I know which ones are going to be the right ones? This is where our calculator really comes in handy. So I'm going to show you a trick on here to quickly find our factors. Because we could sit and guess and check for a long time. It's just too time consuming. If you go to your y equals and you type in this number that we want. Now this number is negative 130. I don't like putting negatives in. That's just my personal preference. I always put the positive in just because it doesn't change our factors. We already know one's negative and one's positive. We're going to do 130 divided by x, and that x button is right there. And then we're going to hit second graph. Now what this does is this pulls up a table of values for us, and these are all the factors of 130. Now there's going to be a lot of decimals listed. We don't care about the decimals. We only want the whole numbers. So we've got 1 times 130. Now let's think, is there any way I can put 1 and 130 here, adding them together and get 3? Logic says no, right? So we can eliminate that one. We've got 2 and 65. Again, those numbers are so far apart. There's no way I can put a 2 and a 65 and end up with a 3. We need some numbers that are closer together. We've got 5 and 26. Getting a little closer, but still way too far apart. What about 10 and 13? Definitely, I'm thinking yes. And just to show you a quick thing before I pull this away. If you wanted to keep scrolling, now we see 13 and 10. Once you see a repeat, so we had 10 and 13, 13 and 10, we saw a repeat, so we can stop. We've seen everything. So now we know our two values are a negative and a positive, and we know that one is a 10 and one is a 13. So we just need to figure out which one needs to be the negative and which one needs to be the positive. And only one of the options will work to give us what we need. So we could try both. So if we had a negative 10 plus 13, that would give us a positive 3. If you reverse it and you said negative 13 plus 10, that would leave us with a negative 3, which is not what we need. We need a positive 3. We know our 10 will be the negative, and our 13 will be the positive. Now that we have our two values, what we're going to do is we're going to come back to this. This is called a quadratic trinomial. And the reason we call it a trinomial is because it's made up of 1, 2, 3 terms, right? A, B, and C. We're going to turn this trinomial into a 4-term problem. And we're going to do that by splitting our B value up into these two new values. So here's what we do. A and our W squared, we just bring down. It's going to stay 2W squared. Our B is going to split up. It's now going to be negative 10W and positive 13W. And notice that I put a W with both of those terms. The reason I did that is because our B term has just a plain W with it. So our new two B terms will also just have a W with them. So our C term, negative 65, we'll just bring straight down. And then we'll have our equals 0. Okay, so now we turn this 1, 2, 3 term into a 1, 2, 3, 4 term. So what we do now is something called factor by grouping, where we group together the first two terms and we group together the second two terms. Now what's really important is with the second two terms that we include the sign. So that plus goes with the 13W, so we're going to include that. Okay, so now we're going to do something called factoring out the GCF, the greatest common factor. And we're going to do it for the first parenthesis set and for the second parenthesis set, one at a time. So let's just focus on the first parenthesis set, 2W squared minus 10W. We want to know what is our greatest common factor between these two terms. So what is the greatest number that goes evenly into 2 and 10? 2 is the greatest common factor. So we're going to pull out a 2. Let's pretend you didn't know that for a second. I'm just going to show you a cool trick on the calculator that you can use to find the GCF if you weren't sure of it. If you go to Math, and then we right arrow over to the second tab, which is Number, and we want to scroll all the way down to 9, or you could just hit number 9. And this says GCD. GCD and GCF are the same thing. Greatest common factor, greatest common denominator, same thing. So now we want to put in those two values we were looking at. Remember it was 2 and 10, and we're not going to put in negative 10. We're just going to put in positive 10. So what we do is we type 2, and then this little comma button, it's right above the 7, and then we'll type 10. Close our parenthesis out and hit enter. Your calculator will go ahead and tell you the greatest common factor between those two numbers. Now I will go ahead and let you know there is a slight drawback, at least for the TI-84s. I don't know if any of the newer ones maybe don't have this drawback, but you can only do two numbers with this. So if you're ever in a situation where you want to know the GCF of 3 or more numbers, this isn't so helpful, but it's helpful for at least 2. So we know the GCF is 2. What about W? Can I pull a W out? Well, this one is W squared, and this one is just W. So that means I can pull one W out. You may be thinking, well, why can't you pull 2 out? Here's the thing, they both, when it comes to letters, they both have to give me the same amount. There's an understood exponent of positive 1 right here. So I can only take what they both can give me. So I can only take 1. Okay, so now that we have our GCF of the first parenthesis, we're going to actually factor it out. And by factor it out, I mean divide it out. We know our GCF is 2W. So for each of these terms, I'm going to divide by 2W. Now here, this is my GCF, so I'm going to show parentheses. It's kind of like saying we're going to pull the GCF out, and here's what's left. So let's figure out what's left. 2W squared divided by 2W. Well, the 2's cancel out to 1. And then W squared It's kind of like saying I had 2 W's, I pulled 1 out, now I only have 1 left. Okay, so negative 10 divided by 2 is a negative 5. I had 1 W, I pulled 1 W out, so there's no W left. Close the parenthesis. So now let's do the same thing for the second parenthesis set. Now, one thing that we always do, and this is why I made a big deal about that sign, whatever that sign is, in this case it's a plus, whatever it is, we pull it out. Okay, you just bring it straight down. And now we think between 13 and 65, what is our GCF? So we can use that GCF trick on the calculator. I'll go ahead and let you know the GCF between 13 and 65 is a positive 13. We can't pull a W out here because even though the 13W has one, the negative 65 doesn't. So I can't pull a W out. Remember, they both have to be able to give me at least 1 for me to be able to pull it out. So now let's factor out, and by factor out I mean divide out, our GCF of 13. So 13 divided by 13 is 1. And then I just have a W left because I had a W, I didn't take 1 out, so I still have 1. Negative 65 divided by 13 is a negative 5. I bring down my equals 0. One of the things I love about this method is right here, we have a way to check and see if what we've done has been accurate. The check is, in our parentheses, we should have twins. We should have the exact same thing here as we do here. Now our next step is to take our 2 values that are in front of the parentheses. So we see that's 2W and positive 13. That's going to be our first parenthesis set. 2W plus 13. Now our twins, W minus 5, we're just going to take 1 twin, and that's going to be our second parenthesis set. And then we still have our equals 0. Now we take each parenthesis set one at a time, and we set them both equal to 0. So I'm going to move that over here. I would take 2W plus 13 and set it equal to 0. And then I would take W minus 5 and set it equal to 0. And now we just solve each equation for W. So for this first equation, I would want to subtract 13 from both sides. And now I just have 2W equals negative 13. And then I want to get W alone, so I divide by 2 on both sides. And W equals, now negative 13 over 2, that does not reduce. I could write it as a decimal, so I could write it either as negative 13 over 2 or negative 6.5, right? Either way is fine. Now for this one, I would want to add 5 to both sides. And I get W equals positive 5. We ended up with 2 different W answers, right? We have this one, W equals negative 13 over 2, or negative 6.5. And we have this one, W equals 5. We have to look at the context of our problem. I know it feels like a while ago that we were talking about the rectangular pool, but remember, this is a real life situation. Would we ever measure the width of a pool and say, oh, this is negative 6.5 feet? We wouldn't, right? That doesn't make sense in the context of our problem. So what we can do is actually throw away our negative answer. We don't need it. This, the positive 5, is going to be our answer. We found half of our answer. We know the width. We know W is 5. So we can actually write that out. W, or the width, is 5. And remember, our units are in feet. So 5 feet. Now we still need to know the length because they wanted to know length and width. So let's think back to what we know about length. We know the length was 2 times W. W is 5 plus 3. Now 2 times 5 is 10, and 10 plus 3 is 13. So we now know the length. The length is 13 feet. Thanks for watching. This has been Miss Smith's Math Tutorials.